Hi everyone, welcome to this channel. Today I thought to solve out this problem that came in ISS 2023 examination in paper 1. So this is a very simple problem on probability and joint distribution like that. But I wanted to solve it out to show how easily it can be solved without going into detailed integration and detailed calculation. We just have to understand the mechanism of the problem and understand the trick that is latent in the problem. So let's begin. So here, as you can see, we are given with the joint probability distribution, the PDF of x and y. And if we closely see the joint probability, we readily understand that it resembles to the normal distribution. The only difference being that here the usual conventional sigma square is not present, but it is there with the conditioned factor y. So if we we can incorporate the sigma square with the conditioning on y, meaning this is a joint PDF of x and y. So this can be written as the multiplication of these two PDFs, x given y times the marginal PDF of y. So if we express the conditional PDF as this, then we readily know this x given y is following some normal distribution with mean 12y comma y. So variance is y, right? And fy is nothing but 1. So we can consider y to be following uniform 0-1 distribution. So given these two information, that x given y is following normal 12y comma y distribution and this random variable y is following uniform 0-1 distribution, these three problems 8, 9, 10 can be solved very easily, right? Let's solve this problem number 8. So they are saying what is the expectation of x. So we know that expectation of x is nothing but double expectation of x given y. We know expectation of x given y is 12y because x given y is following some normal distribution with mean 12y and variance y. So it is nothing but 12 into half, because y is following uniform 0-1 distribution. So the answer is D. Now we have to calculate variance of x. So variance of x is nothing but expectation of conditional expectation of variance of x given y and plus variance of conditional expectation of x given y. So here it is nothing but y plus variance of 12y. So we know the expectation of y is half, and it is 144 into variance of y. What is the variance of y? The variance of y would be 1 by 12, right? So this is nothing but 12.5. So answer is D. Now we have to calculate this covariance of xy. Covariance of xy is nothing but expectation of xy minus expectation of x into expectation of y. Now we readily know that expectation of x is 6. We know that expectation of y is half. So we know these two quantities. We have to calculate only this quantity expectation of xy. So what is expectation of xy? So expectation of xy is double integration xy into fx given y times fy dx dy, right? This is nothing but by definition. And if we consider the limits, for x it is minus infinity to infinity, for y it is 0 to 1. So just have to arrange it. We bring it y here, if y dy times minus infinity to infinity x times fx given y dx. Now we know that if y is nothing but 1, so it is if y dy, and we know that this quantity is nothing but the expectation of x given y, which is 12y, right? So 12y, and we'll be having what, 12y square integration 0 to 1 dy. So we'll be having 12/3, which is 4. So here if we put it, we are getting 4 minus 3, which is 1. So 1 is the answer. So this is how we can easily solve out this problem with a simple trick. So we didn't do any double integration or integration to calculate the expectation of x or the variance of x, but we just identified the conditional distributions and consequently solve the problem. Thank you for watching the video.